All right, let's get right into it. Today, we are going deep on generative AI, the technology that is, let's be honest, changing just about everything. We're going to go under the hood and really figure out how it works and what it means to build an artist right inside the machine. You know, for decades, we've seen AI as this amazing tool for analysis, right? It could spot a trend, find an error, predict an outcome. But that brings up a really cool question. What happens when that tool picks up a paintbrush? What if an AI could not only analyze our world, but actually create brand new parts of it?
Okay, so to really get this, let's use a simple analogy. For the longest time, AI has been the critic. It's incredible at looking at something and telling you what it is. It classifies, it predicts, it judges. But now we have the artist. This is generative AI. Its job isn't to judge what's already there, but to create, to synthesize, to generate something totally new.
So let's really dig into that shift. For most of its life, AI was a master at telling things apart. It could tell you if a photo was a cat or a dog with almost perfect accuracy. But if you asked it to draw you a cat, it wouldn't have the first clue where to start. It was a brilliant art critic, but it couldn't make any art itself.
Now, what's really fascinating here is the difference under the hood, mathematically. The critic, that's discriminative AI, it just needs to learn the boundary between things. In nerdy terms, that's the probability of a label given the data. But the artist, generative AI, has a way harder job. It has to learn the joint probability. It has to understand the entire underlying structure of the data itself. It's not just learning the line between a cat and a dog. It's learning the very essence of what makes a cat a cat.
So, this brand new artistic superpower? It comes from something you've definitely heard about, the large language model, or LLM. So how on earth does this prediction engine actually work? You hear this all the time, right? Oh, it's just fancy autocomplete. And look, on a super technical level, that's not totally wrong. The core job of an LLM is to predict the next word in a sentence. But calling it just autocomplete really misses the mind-blowing complexity it takes to do that well.
So let's put that simple autocomplete idea to the test. Here's a classic riddle for you. The surgeon could not operate on the patient because he was his son.
So who is the surgeon? For us, it's obvious, right? It's the patient's mother. But for an AI to get that right, what does it really need to know? This goes way beyond just knowing which words tend to follow other words.
To solve that riddle, the AI needs to understand things like logic, causality, family structures, gender roles, this whole complex web of how our world works. So here's the absolute key. To predict the next word with any real accuracy, the model is forced to build its own internal statistical map of reality. It's not a parlor trick, it's world modeling. And the way it starts to read our world is through something called tokens. Before an LLM does anything, it shatters our language into these little numerical pieces. It lets the model handle a huge vocabulary and turn complex ideas into math. This is step one. This is how it all begins.
Okay, but how do those little tokens become coherent sentences or even ideas? Well, for that, we have to talk about probably the single biggest breakthrough in modern AI, an architecture called the transformer and its superpower, the attention mechanism.
See, before transformers, we had these older models like RNNs, and they had a huge problem. They had to read one word at a time, sequentially. This was a massive bottleneck, and they'd often forget the beginning of a sentence by the time they got to the end. Transformers completely changed the game. They look at all the words at the same time, in parallel, and that unlocked incredible speed and scale. But wait a minute. If you're looking at all the words at once, how do you know which ones actually matter for understanding the meaning? That is the magic of self-attention. It's a system that lets the model weigh the importance of every single word in relation to every other word. It builds this rich map of context.
And here's a great way to think about it. Imagine you're at a super loud cocktail party. An old RNN would have to listen to every single conversation one by one. It would be totally lost. A transformer with self-attention can hear the entire room at once, and then dynamically turn up the volume on the one conversation that matters to you and tune all the other noise out. It can focus.
So how does it actually do that focusing? Well, it boils down to three things for every single token: a query, a key, and a value. Think of it like a dating app. Your query is your profile, what you're looking for. The key is everybody else's profile, who they are. The model zips through comparing your query to every single key to see who's a good match.
The value is like the actual substance of the best matches, their phone number, their interests, which then becomes the basis for the final output. It's a really elegant way to find what's relevant.
Okay, so we've got the blueprint, the transformer architecture. Now let's head over to the factory floor and see how we actually build one of these things. Let's look at the AI assembly line. The whole process really has 4 big stages. First up is training. This is the gigantic, super expensive process of building the base model from scratch. Then you have fine-tuning, where you take that general model and you specialize it. After that comes inference. That's when the model is actually doing work, answering your questions. And finally, there's serving, the massive engineering challenge of delivering that model to millions of people at the same time.
And when I say that initial training phase is massive, it is almost impossible to wrap your head around it. We're talking about training a model on a library of text that can be over 1 trillion words. That incomprehensible scale is exactly what forces the model to build that internal map of the world we were talking about earlier.
But here's the thing. A raw model trained on the internet, it's like a brilliant child who was raised by wolves. It knows a lot, but it has 0 manners. So the next step, and you could argue it's the most important one, is alignment. This is where we teach the AI to be helpful, harmless, and to act in a way that reflects our values.
And this is mostly done with 2 different techniques. On one hand, you have supervised fine-tuning, or SFT. Think of this as the teacher. You show the model thousands of perfect human-written examples, and you say, do it just like this. On the other hand, you have reinforcement learning from human feedback, or RLHF. This is more like the guide. You let the model try a few different answers, and a human just tells it which one they liked best.
So the key difference is their goal. SFT is about teaching the model a specific skill or format. It's great for things like learning to write code. RLHF is about shaping its personality and its preferences, things like being polite or avoiding dangerous topics. It's not about what the right answer is, but what a good answer feels like. And pretty much all the models you use today are trained with a mix of both.
And we absolutely have to talk about the unsung heroes in all of this, the thousands of human labelers. These are the people writing the SFT examples and ranking the RLHF answers. They are, quite literally, defining the ground truth for what it means for an AI to be good or helpful. Their perspectives, their judgments, their biases, that is what directly shapes the personality of the AI we all talk to every day.
So let's just tie this all together. It all starts with a task that sounds almost laughably simple. Just predict the next word. But when you do that at a massive scale, you force the model to do something truly profound. It has to learn the patterns, the logic, and the relationships of all human knowledge. It has to build a statistical map of our world.
And that brings us right back to where we started. The critic has finally become the artist. The tool that could only analyze our world can now add to it. And that leaves us with what might be the most important question of our time. As we hand this AI a paintbrush, a keyboard, or a musical score, how will we choose to direct its artistry?